So if you look at this problem, it says the temperatures for a month for a city are normally distributed with mu equals 81 degrees and standard deviation equals 6 degrees. So find the probability that x is between 70 and 90. So what we're going to have to do here is we're going to have to find two sets of z values. The first z value will be for 70. Okay, so that's what we're going to do right now. So we're going to go ahead and take 70 minus 81 and divide that answer by 6. And when we do that, we get negative 1.83. Now what we're going to do is we're going to do the same thing, except for we're going to have to use the 90 value. And so in this case, I get 90 minus 81, all divided by 6. And so once again, if I go ahead and take 9 and divide it by 6, I get 1.5. And so what happens is if I look at this in a normal distribution, I have two values here. I have the negative 1.83 right here, and then I have the 1.5 right here. Now remember from yesterday we learned that in the middle is our mean, which is 0. And so what I'm trying to find right now is I'm trying to find what percent of values lie in this area right here. And so remember, yesterday we looked at a way to do that, and that was using the normal CDF function. So in this case, I'm going to do the normal CDF. Now, one of the things we talked about yesterday is that the first value is our leftmost point. So our leftmost point in this one would be negative 1.83. Our rightmost point would be 1.5. And then remember, we always have to attach the two data values on the end, 0 and 1. So I'm going to let you go ahead and enter those in. So our lower value is at negative 1.83. Our upper value is at 1.5. And then we have 0 and 1. Now when I calculate that, I end up getting 0.8996, which comes out to be 89.96%. So let's see what that means. That means that 89.96% of the time you will have temperatures between 70 and 90 degrees. Okay, let's go ahead and look at another problem. The temperatures, okay, for a month for a city are normally distributed, okay, with the same mean of 81 degrees and sigma of 6 degrees. And so now notice this one, the difference is that we're looking for the probability that x is greater than 95 degrees. So we're trying to figure out if we want a value bigger than 95, what percent of the time will that occur? Very first thing, once again, you need to find the z value. So I'm going to take 95 minus 81, all divided by 6. And so if I take 95 minus 81, and divide it by 6, I get my answer to be 2.33. Now when I think about a normal distribution, here is going to be my 2.33 right here. Now if I look at the problem, they say the probability that x is greater than. So greater than means this value right here. So if I'm going to do my normal CDF, I've got my normal CDF function again that I'm going to type in. I've got my leftmost point, which my leftmost point in this case is 2.33. My rightmost point is all the way here at positive infinity. So remember, we symbolize positive infinity with E99. We're going to do 0 and 1. So if I go ahead and enter those in, I end up getting my answer to be 0.0099. So if I write that as a percent, I get 0.99%. So that's something that doesn't occur very often, okay, at least in this month. We've got less than 1% chance that we're going to get a temperature of greater than 95 degrees. Very last problem we're going to look at today. The scores on the standardized test are normally distributed with mu equals 72 and the standard deviation equals 11. Find each probability. So we have two values here. So the probability that x is less than 89. So what I'm going to do is find my z value here. And once again, I get 89 minus 72 over 11. That z value comes out to be 1.55. It's actually 54 repeating, but remember we always round to 2 decimal places. And so if I think about the normal distribution, 1.55 is going to be located up here. And I want the probability that it's less than, so I'm going to look for this value right here. So using my normal CDF function, my leftmost point will be negative infinity. So negative infinity, remember we symbolize as negative E99. My rightmost point is 1.55, and then I always have to add in 0 and 1. So if I calculate that, I end up getting an answer of 0.9394. If I answer that as a percent, I end up getting 93.94. Now notice this one said find each probability. So when we're referring to probability, probability is an answer between 0 and 1. So we really wouldn't use the percent, we would actually use the 0.9394 instead. Okay, this next one says find the probability that your score is between 65 and 85. So you've actually got two z values we need to find. We need to first of all find the 65. So if I take 65 minus 72 and divide that by 11, I get negative 0.6363, which will round up to negative 0.64. Now what I'm going to do is find the same z value for 85. So 85 minus 72 divided by 11. So if I calculate that, I end up getting 1.18 repeating, which would be 1.18. If I think about my normal distribution then, what my graph is going to look like, I have two values here. I have a negative 0.64 and I have a 1.18. Now remember again, I'm writing those in reference to my mean of 0. And so what I'm wanting to find is this area in between here. So if I do my normal CDF function from yesterday, my leftmost point is my negative 0.64. My rightmost point is 1.18, and we always have to add in the 0 and the 1 for the mean of the standard deviation. So if I go ahead and calculate that, I end up getting 0.6199, and if you remember, we just talked about the fact that if you're finding a probability, your answer doesn't need to be in percent. And so your answer there would be 0.6199. Now, fourth period, we did have a little bit of a change from yesterday. This is the updated assignment, just in case you didn't get that down. But it's on pages 681 through 682, 2 through 10 the evens, 18, 20, 23 through 26. This will be due Tuesday. We will probably have a quiz Tuesday as well. And for Thursday, those of you that are going to be gone, there is a worksheet. And so what you need to do is make sure you get that worksheet before you leave today on Wednesday, if in fact you're going to be gone tomorrow. Those of you that are here Thursday, you will have Thursday to work on that worksheet as well as this assignment. So have a great weekend. Enjoy your Easter break.